Good morning, everyone. Good morning, and welcome back again to your Unacademy NEET English channel. Can you quickly let me know if all of you can hear me, if I'm perfectly audible, visible to every one of you? Good morning, people. Good morning. Good morning. So quickly, let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Good morning, people. Good morning. Good morning. So, as you all must be knowing, a few days back, we have launched one more series, right? Which is going to be the question practice series. And this question practice series, which will happen basically in the morning slots, right? All the sessions are going to happen at 11 a.m. in the morning, in which from every chapter of your physics, chemistry, and biology, we are going to do 100 most expected questions, right? So today is the first session of it, and today we shall be doing the most expected questions from the chapter General Organic Chemistry. Basically, you guys are going to solve the question. I'll be helping you out in order to solve these questions. Okay? And in your evening slot, Game of NEET is going to run as usual, right? You know it. Game of NEET is going to run as usual in the evening slots, and in the morning slots, we are going to have the chapter-wise most expected questions, be it physics, be it chemistry, be it biology. For example, today I'm taking the question practice session. Tomorrow it's going to be Yavar sir. Day after tomorrow it's going to be Ambika ma'am, right? So in the similar way, the morning slots will be occupied on this channel from now onwards. Yeah? Just tell me one thing. Just tell me one thing. Let me know whether you have watched the General Organic Chemistry session on YouTube, which I took like 2-3 weeks back. Have you completed this particular chapter? Have you completed this particular chapter? Let me know quickly. Are you done with that? Are you done with that particular chapter? GOC, which I completed, I guess, 3-4 weeks back on this channel. That is great. That is great. If you have watched that session, then I'm pretty much sure you are going to solve all the questions which I have come up with from the chapter General Organic Chemistry in the today's session. Okay? And you have to be very, very, very active in the chats today. Because whatever questions I'll be showing you on the screen, you have to keep on letting me know the answers in the chats. Okay? So, chat box has to be very, very, very active today. Right? Today it is GOC. Tomorrow it is going to be, tomorrow in the morning, it's going to be electrostatics top 100 questions. Right? Tomorrow it's going to be electrostatics top 100 questions. And by the way, before starting the session, let me tell you, 1 hour before I posted one amazing strategy video for all the NEET 2024 aspirants. Do watch that afterwards. Right? That is one amazing strategy video in which I explained everything. I addressed all the students who are scoring less than 250 in their mock tests, all the students who are scoring almost 450 in their mock tests, and all the students who are scoring almost 600 in their mock tests. How do you scale up your marks in the mock tests? That is everything mentioned in that particular strategy video, which I posted like 1 hour before. Yeah? Correct? Okay? So I would request you guys to watch that video after this particular session. That is going to be like beneficial for you, for sure. Chalo, let's get going then. Let's get started, and you guys are going to let me know the answers of all the questions. And before starting this particular session, the ones who are not like the session yet, I would want every one of you to like this session right now. Do share this particular video with everyone, and do subscribe to the channel as well. Okay, do subscribe to the channel as well. Perfect. And one more thing, before starting, one more thing. On 15th of this month, we are going to do a one-shot of thermochemistry, right? And after that, it's going to be a one shot of atomic structure. Complete atomic structure in one shot. Perfect, right? These are the upcoming 2 sessions which I'll be taking on this particular channel. So remember the chapters which I'll be taking. Thermochemistry on 15th, that will be a live session. And atomic structure, that will be of almost 9 hours, but that I'm going to post as a recorded session. That's a complete atomic structure which I'll be posting. Yes, in the game of NEET. Yes, in the game of NEET. Yeah? Perfect, perfect, perfect. All right, people. So let's get started with the first question, which is a very simple and the basic question. And I'm pretty much sure every one of you can easily solve this basic question. So what do you think should be the answer of this question? Which of the following possesses a sp carbon in its structure? In which of the following structures do you see the sp hybridized carbon? Quickly, 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 quickly. This question has to be solved in less than 10 seconds. This question has to be solved in less than 10 seconds. So what do you think about this one? Majority of the students are coming up with option C, and I believe you guys are right. It's absolutely option C, which is the correct answer. Because in the option C, if you can see, we have got 1 sigma and 2 sigma bonds. This carbon is forming 2 sigma bonds, 2 pi bonds, right? So if this carbon is forming 2 sigma bonds, so definitely hybridization of the central carbon over here is going to be sp, because its steric number is 2. Steric number 2 means hybridization sp. Simple and basic question this is. And I believe every one of you solved this particular question properly. Okay, before moving on to the next question, can you tell me the hybridization of this carbon quickly? I want to see whether you remember it or not. What is the hybridization of this carbon? Quickly. It is forming 2 sigma bonds with hydrogen, 1 sigma bond with carbon, right? So 3 sigma bonds. 3 sigma bonds means sp2. Correct? What about the hybridization of this carbon? Quickly. Quickly. What about the hybridization of this carbon? 1 sigma, 2 sigma, and 1 with chlorine. This again sp2. Perfect. What about the hybridization of this carbon? Quick. Hybridization of this particular carbon. Quick. 1 sigma, 2 sigma, 1 with hydrogen. So sp2. This one, again sp2. Similarly, if you look at the third structure, this one, this particular carbon, can you let me know its hybridization? It is forming in total how many sigma bonds? 2 with hydrogen, 1 with carbon. So 3 sigma bonds, that means sp2, right? 2 sigma bonds, sp. 3 sigma bonds, this is also sp2. I believe this is something which you all must be knowing from now on. Okay, quickly, what do you think about this particular question? The question has been asked in your NEET 2017. The correct statement regarding electrophile is, these are some definitions which are mentioned over here. You have to check which one is the correct statement about the electrophile. Electrophile, as per the name is concerned, electrophile, electron-loving species. Electron-loving species. Electron-loving species. Quick, everybody, everybody, quick. Electron-loving species. All of you are coming up with the correct answer. That is absolutely right. Wonderful, guys. Electrophile, it can be either neutral. It can be either neutral or can be positively charged species, right? And can form a bond by accepting a pair of electrons from the nucleophile. This is the correct definition of your electrophile, right? Electron-loving species, which can be either neutral or can be positively charged and can accept a pair of electrons from what? From a nucleus-loving species, right? Easy question this is. The question was asked in your NEET 2017. All right, there is one more question which was asked in NEET 2017. I want you guys to let me know about this one. Quick. Which of the following is an electrophile? Which of the following is an electrophile? Less than 10-second question. Less than 10 second. Electrophile, electron-loving. Electrophile, electron-loving. It can be neutral or positively charged. You know it. It can be neutral or positively charged species. What do you think? Quickly, what do you think? Quickly. Quick. Not everyone is coming up with the right answer. The answer is absolutely going to be option A. CCl2, dichlorocarbene, right? Perfect. If you look at this particular carbon, how many electrons it has? 2, 4, 6. 6 electrons. Over here, completely filled 8. 8 as well as 8, because here you have got the lone pair. Here you have got 2 lone pairs on oxygen. Perfect. So this carbon contains 8, this oxygen contains 8, this oxygen contains 8. So which one is electron deficient? Which one do you see is the electron deficient? It is the first one, right? Perfect. So CCl2, right? This is going to be the example of the electrophile over here in this case. A pretty much simple question. These are 3 questions. These are 3 questions which easily you can solve. I'm pretty much sure. 1, 2, 3 and 4. You have to arrange them on the basis of their stability order. You have to arrange them on the basis of their stability order. 1, 2, 3, 4. Quick. And this is the negative charge at the top. Negative charge at the top. Quick. Negative charge at the top. Quick. Everyone. Negative charge at the top. See guys, if you remember, this is a 3-membered ring, 4-membered ring, 5-membered, 6-membered. Less membered ring is more electronegative, you know it, already discussed. Angle strain concept. Here you have got more angle strain means more electronegativity. Correct? Perfect. And negative charge is more stable on more electronegative. Negative charge is more stable on more electronegative. So what has to be the stability order? It is 1, 2, 3 and 4. Correct? Now you have got the positive charge everywhere. Positive charge everywhere. Positive charge is more stable on less electronegative. Positive charge is more stable on less electronegative. Which one is less electronegative? The last one. At the last one, the positive charge is going to be more stable. Now, among these two, I just want to see how much you guys remember. Among these two, 1 or 2, where do you see stability more? 1 or 2, where do you see stability more? 1 or 2? 1 or 2, quick. Guys, do not think a lot about these questions. I have given you the concepts long back in the marathon itself. What is the order here? What is the order here? See guys, if you see, this is your sp hybridized carbon. This is your sp3 hybridized nitrogen. sp3 hybridized nitrogen. And you know, the electronegativity of sp hybridized carbon is more than that of electronegativity of sp3 hybridized nitrogen. You should know this. I have told you this long back. Electronegativity of sp hybridized carbon is more, right? Electronegativity of sp hybridized carbon is more. You know, negative charge is more stable on more electronegative element, right? So negative charge will be stable on this particular carbon. So this is the stability order. 1 will be greater than 2. Agreed? I'm pretty much sure this is done. All right, look at this particular question. ABC. ABC. Check the stability order. ABC. ABC. Check the stability order quickly. These are carbocations. And you know, carbocations are stabilized by electron donating groups. Carbocations are stabilized by electron donating groups. Electron donating groups. This CH3, CD3, NO2. Right? Look at the groups. Look at the groups. Look at the groups. This is going to operate from the meta position. It's going to operate plus I. This will also operate plus I. From the meta position, this is going to operate minus I. Right? So donating group, withdrawing group, right? And you know, your carbocations are stabilized by electron donating groups. So stability of 1 and 2 will be definitely more than that of 3. So C is the least stable because here you have got withdrawing group. Now among these two groups, which one is more donating? Which one is more donating among these two? I'll say CD3. So B followed by A followed by C is the order. What do you think about this one? What do you think about this one? What do you see the stability order here? What do you expect the stability order here? Quickly. You have to write the answers in the chats quickly. You have to write the answers in the chats quickly. What do you think? Everybody in the chats. Everybody. I told you, you have to be involved in the chats. Quick. Quick, guys. This nitro is electron withdrawing. This is electron withdrawing. And over here, you do not see any electron withdrawing groups. Electron donating groups, they stabilize the carbocation. Electron withdrawing groups, they destabilize the carbocation, right? So over here, no electron withdrawing group is attached. So A will be maximum stable. Now among B and C, here electron withdrawing group is close by. It is close by, right? So it will be prominent here, right? So its stability will be the least. So C will be the least stable and this is going to be B. So A, B, C directly is going to be the order here. I believe everybody has already mentioned it in the chats. That's wonderful. Similar sort of question I'm going to give you. Let me see if you can solve this one or not. And I believe you can easily. Because these sort of questions we have already solved in the marathons. These type of the questions. Can you give it a try? Can you give it a try, people? Quick. People are saying CBA, is that? Again, if you look at all the species, these are all carbocations, right? These are all carbocations. So this is your electron donating. This is your electron donating here, electron donating here. Where is the electron donating group closer towards the positive charge? In the third case, so here, it's going to be more prominent. So C will be maximum stable, followed by B, followed by A. Everybody wrote the same answer, CBA? Right? Everybody wrote the same answer, CBA? What about the next one? What about the next one? Quick. The next one. Stability order. These are again the carbocations. These are again the carbocations. Right? Look at this particular group. This particular group is donating. This particular group again donating. This particular group again donating. And they will show plus I for sure. Right? They'll show plus I. Plus I group, and this is also plus I group because all these groups are alkyl groups basically. And your alkyl groups, they show plus inductive effect. You know it. They show plus inductive effect. Now, which one will show maximum plus I here? This is maximum branched, comparatively less, least branched. So, B's stability will be more, followed by C, and then it's going to be A. Right? B, C, A is going to be the order here. Right? I believe majority of the students came up with the right answer. That's wonderful. I'm going on to one more question. NEET 2019. See what kind of question was asked. The most stable carbocation among the following is. The most stable carbocation among the following is. Where do you see the carbocation most stable? You know, normally we say carbocations are stabilized by hyperconjugation, right? Carbocations are stabilized by hyperconjugation. So wherever you see more alpha hydrogens, directly its stability will be the maximum. More alpha hydrogens means more stability. So what do you think? What do you think? Quickly, guys. Quickly. See, if you look at the option D, right? This is your sp2 hybridized carbon. Adjacent to it, this is your sp3 hybridized carbon. I'll be calling this as alpha carbon, right? Similarly, sp2 adjacent to it, this is sp3. I'll be also calling it as alpha carbon. The hydrogens attached with this alpha carbon are 3, right? Over here, 2. So in total, how many alpha hydrogens do we have? 5. So this carbocation is stabilized by 5 alpha hydrogens. This carbocation is stabilized by 4 alpha hydrogens, right? So more the alpha hydrogen stabilizing carbocation, definitely more is going to be its stability. So in the option D, as I can see, you have got more alpha hydrogens. More alpha hydrogens means more stability. I believe this is again clear to you. Okay, among first and second, where do you see the stability more? Sulfur carrying negative, oxygen carrying negative. Where do you see the stability more? Where do you see the stability more? Where do you see is the stability more? First or second? First or second? Quick. Where do you see the stability more? First of all, you need to identify whether oxygen and sulfur, do they belong to same period or same group? Oxygen and sulfur, they belong to same group, right? Whenever you see stability of charges on the elements which belong to same group, you see it on the basis of volume charge density. Volume charge density, which is charge on the species divided by size of the species, right? And you must be knowing now, volume charge density is inversely proportional to stability. That's it. Now here, oxygen carrying negative, sulfur carrying negative. Charge in both the cases same. Now look at the size. Here the size is more the size, lesser the VCD, more the stability. So first is going to be more stable than that of second, right? As per volume charge density rule. We have discussed it in the marathon as well. Okay, negative on carbon, negative on nitrogen. It is the same question which we did a few minutes back. This is sp hybridized carbon. And this is sp3 hybridized nitrogen, right? Electronegativity of sp hybridized carbon is more. And negative charge is more stable on more electronegative. You know it. Negative charge is more stable on more electronegative. You know it. So one will be more stable than that of two, right? I hope you guys are easily solving these questions on your own. Okay. Stability of carbanions. Stability of carbanions. You know, your carbanions are stabilized by? Carbanions are stabilized by what? Carbanions are stabilized by electron withdrawing groups. Carbanions are stabilized by electron withdrawing groups. Quickly, A, B or C? Where do you see the stability maximum? A simple and basic question this is. See, this is electron donating, right? This is electron withdrawing. This is also electron withdrawing. And electron withdrawing groups, they stabilize the carbanion. So which group is more electron withdrawing? C. So C stability will be maximum, followed by B, followed by A. Let me see your chats. C, B, A. I believe everyone is writing the same. That's great. Okay, look at the next one. Look at the next one. Again, you have got carbanions. Again, you have got carbanions in this particular case. And here you have got NF3 positive, fluorine, CD3, right? This NF3 positive, it is electron withdrawing. You know it. This is also electron withdrawing. You know it. This is electron donating. You know it. Correct? Now, electron withdrawing groups, they stabilize the carbanion. Now, which one is more electron withdrawing? Is there going to be NF3 positive or F? NF3 positive is more electron withdrawing. So, A's stability will be maximum, followed by B. And at the end, it's going to be C. Right? At the end, it's going to be C. And guys, after this session, you guys are going to let me know in the comment section which chapter do you want the next for the question practice, right? I'll follow the sequence what you say, right? Whatever majority says in the comment section, not in the chats, in the comment section. What majority says, I'm going to come up with the same chapter, okay? Right? And try to give the chapter which we have already completed in Game of NEET. Yeah? Try to give a chapter which we have already completed in Game of NEET. All right, A, B or C? A, B or C? A, B or C, quick. Stability order, quickly. Stability order, quickly. If you see over here, oxygen is attached, right? Oxygen is attached. Here also oxygen is attached. Here also oxygen is attached. But here nothing is attached, right? No oxygen. Here oxygen is comparatively close. Electron withdrawing group is completely close, comparatively close, right? So directly you can say stability of B is maximum, followed by A, followed by C. No need to give it a thought. What about this one? What about this one? This is here CH3 and CH2. Okay. Now, A, B, C, and D. What do you see the stability order here? What do you see the stability order? A, B, C, or D? What do you think? A, B, C, or D? Quickly, guys. Quickly, A, B, C, or D? If you remember in the GOC marathon, in the first hour itself, I have given you these sort of questions. I hope you remember. And these are your in-text questions, by the way. These are your in-text questions, by the way. See guys, again it's pretty much simple. Sulfur is carrying negative, oxygen is carrying negative, nitrogen is carrying negative, carbon is carrying negative. Now first of all, if you look at first and second example, sulfur carrying negative, oxygen carrying negative. Oxygen and sulfur, they belong to same group, and whenever elements belong to same group, you have to talk in terms of VCD, volume charge density. So size is more size, less VCD, more stable, right? So A will be more stable than B. A will be more stable than B. We know it. Now look at B and C. Look, let's compare B and C once. Oxygen carrying negative, nitrogen carrying negative. They belong to same period. In the period, we talk in terms of electronegativity. You know it. And negative charge is more stable on more electronegative element. Negative charge is more stable on more electronegative element. So I would say B's stability is more than that of C. B's stability is more than that of C. Now C and D. Nitrogen carrying negative, carbon carrying negative. They belong to same period. Again, electronegativity. Right? Negative charge is more stable on more electronegative. So C's stability is more than that of D. So what should be the order as per this? A, B, C and D has to be the order. That's all. No need to think a lot about this. Correct? A very simple and basic question this is. Alright. Among A and B, which one you think is more stable? It is evident now. This is your Carbanion, this is Carbanion. More electron withdrawing, so more stable. Right? Among A and B, fluorine carrying negative, iodine carrying negative. What do you think? Fluorine carrying negative, iodine carrying negative. What do you think? Quick. Fluorine carrying negative, iodine carrying negative. Quickly guys, you have to solve this. First of all, fluorine and iodine, do they belong to same period or same group? They belong to same group. And in the group, it is volume charge density which is going to decide. Right? VCD is charge divided by size. And VCD, it is inversely proportional to stability. You know it. Right? So, iodine has got more size, less VCD, more stability. So, B will be more stable than that of A. B will be more stable than that of A. Is it clear, people? Is it clear? No second thought for this question. Okay, NEET 2018. Stability of Carbanions. Stability order of Carbanions, quickly. Stability order of Carbanions. These are all Carbanions. This is a simple and basic question, guys. You have to kill this. This is a less than 10-second question. You should not take a lot of time for this. Here you have got triple bonded carbon, double bonded carbon, single bonded carbon. Triple bonded carbon absolutely will be having more S character, more electronegativity. And you know negative charge is more stable and more electronegative. So this has to be the order directly. Why you are taking a lot of time for this? Right? Why are you taking a lot of time for this? Okay, again in NEET 2018, there was one more question which was asked. See. Which of the following is correct with respect to minus I? Which one shows more minus I? More minus I. What do you think? More minus I. More minus I. Quickly, guys. Solve it. I mean, there is nothing to solve here, yaar. What? Plus saying C. Some are saying D. Guys, it is minus I. Minus I. Please. Please. Use some common sense. Imagine I've got a carbon chain. And with the carbon chain, over here, I've got NH2. Similarly, with the carbon chain, there can be OR as well. With the carbon chain, there can be F as well. The first atom which is attached to carbon chain is nitrogen. The first atom which is attached to carbon chain here is oxygen. The first atom which is attached to carbon chain here is fluorine, right? And electronegativity of fluorine is more than that of oxygen, more than that of nitrogen. So which one will be more electron withdrawing here? Fluorine. Why you are taking a lot of time for this? Right? So all the three will show minus inductive effect. Now which one will show more minus among the three? Here fluorine is attached directly, oxygen is attached, nitrogen is attached. Fluorine is more electronegative, right? So more electron withdrawing. So F has to be maximum followed by OR followed by NH2, right? Perfect. So this is the order, option A. Correct, people? Got it? I hope you got what I said. And you have to be careful with all these things. You have to be careful. These small things do happen in organic chemistry, right? These small things do happen in the organic chemistry. Okay, 1, 2, and 3. These are three resonating structures. You have to arrange them on the basis of their stability. You have to arrange these resonating structures as per their stability. Quick. Quickly, guys. So whenever I see the questions based on the stability of the resonating structures, first of all, I count the number of covalent bonds, right? I mean the internal covalent bonds. 1, 2, 3, 4, 5, 6. 6 bonds you have. 1, 2, 3, 4, 5, 6. Again 6 bonds you have. 1, 2, 3, 4, 5, 6. 6 bonds you have. Since the bonds, covalent bonds are same everywhere, so you cannot decide on the base of bonds, right? You cannot decide on the base of bonds. If bonds were different, then you could have decided. More the covalent bonds means more the stability, right? But over here, bonds everywhere are same, right? So you cannot decide on the base of bonds. Now, what is the rule left? After checking the bonds, what do I have to check? I'll be checking, is there any resonating structure in which the atoms do not carry any charge? Quickly. Is there any resonating structure in which the atoms do not carry any charge? That is the first resonating structure. So it will be maximum stable. A will be maximum stable, right? Now, among B and C. This is charged one, even this is charged one. Now, how do you check here? How do you check here? Quickly, guys. Quickly, what do you think? Quickly, B or C? Look at this oxygen. This oxygen is carrying negative here. Even this oxygen is carrying negative here, right? But if you look at this case, nitrogen carrying positive, oxygen carrying positive. Nitrogen carrying positive, oxygen carrying positive. Positive charge is more stable on, less electronegative. Positive charge is more stable on, less electronegative. Nitrogen being less electronegative than oxygen. So ACB has to be the order, right? ACB has to be the order. There is no need to give it a second thought. No need to give it a second thought. Okay. What do you think about these three? What do you think about these three? Vijay is asking, anyone rate the Avengers batch out of 10? Vijay, Avengers batch is completed. Do you know that? Its revision is also done. Okay. Now there are full-length tests which are happening in Avengers batch on every Sunday. Quickly. What do you see the first thing? Total number of bonds. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. More bonds, more stability. Right? Less bonds, less stability. Okay. So, 7. I mean, B is the least stable. B is the least stable as per the bonds criteria. Leave the bonds criteria aside now. B is the least stable. Now among A and C, atoms of in A do not carry any charge. Atoms in C, they carry the charge. Neutral species considered to be more stable, right? So A followed by C followed by B. Did you all write the same thing? Vijay, if you are 2025 aspirant, there will be an upcoming batch for you. Do not enroll in any batch which we have already taken, okay? Right? Just wait. Do not enroll in any batch yet. All the NEET 2025 aspirants. There'll be a different separate batch coming for you. Perfect. Now among these two, arrange them on the basis of their stability order. Quickly. Arrange these two on the basis of their stability order. Count the bonds first. 1, 2, 3, 4, 5. Count the bonds here. 1, 2, 3, 4, 5, 6. Directly on the basis of bonds also you calculated, right? More bonds, more stability. More bonds, more stability. So B is more than that of A. Right? B is more than that of A. Done and dusted. Correct? What do you think about this one? Which of the following is least resonance stabilized? Which of the following is least resonance stabilized? Least resonance stabilized. Quick. Least resonance stabilized. Exactly. The channel is close to 100K, right? Right? Make it to 100K soon. Least resonance stabilized. Why you are saying option D? I just want to see the logic as well. Like what you guys are thinking. Why you are saying option D? Why? Why? Quick. Why you are saying option D? Quickly. Let's look at the first case. 246, 6 pi electrons. 246, 6 pi electrons involved in the cyclic conjugation. 246, 6 pi electrons involved in the cyclic conjugation. Right? Perfect. Look at this carbon, this sp3. Right? This aromatic, this is aromatic, this is aromatic. And this has to be non-aromatic. Right? Is it done? Is it fine now? There were some connectivity issues. What connectivity issues exactly? The Wi-Fi pack had gotten over. Yeah? Now it's fine. All clear? All clear, people? Okay, let's continue then. Huh? Let's continue then. Let's continue. Okay, this was the question. Among the following, the least stable resonating structure is? The least stable resonating structure among all. The least stable resonating structure among all. What do you think about this particular question? I'm not going to take more than like 15 to 20 minutes. Just wait, okay? You need not to worry. Quickly. The least stable resonating structure is? If you look at the first option, my dear students, in the first option itself, you have got two like charges at adjacent position. Positive, positive. Two like charges at adjacent position. So it will be highly unstable, right? It will be highly unstable. You should know it by now. Among these three, which one, I mean, you have to arrange them on the basis of their stability. Arrange them on the basis of their stability, quickly. What do you think? How do you check the stability of the resonating structures? First of all, you have to calculate the total bonds. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Bonds everywhere are same, right? After this, look at that resonating structure whose atoms do not carry any charge. That is A. So first is maximum stable. Now, among 2 and 3, positive charge on nitrogen, positive charge on nitrogen, negative on carbon, negative on carbon, right? These are unlike charges. Lesser the distance between the unlike charges present on the same atoms, lesser the distance between the unlike charges, more is going to be the stability. So 2 is definitely going to be more stable than that of 3. All this is discussed in detail. I believe you remember. I believe you remember. Yes. So ABC is going to be the order. Okay, what do you think about this one? What do you think about this one? What do you think about this one? Vijay, I don't know who is telling you what. Avengers batch, that was a live batch. I'm talking about Avengers batch. I'm not talking about Avengers 2.0 or 3.0. 2.0, 3.0 had some percentage of recorded lectures, but Avengers batch, which we started in the month of May, June, that was completely live. Okay, it is. I was teaching live. There were a lot of students joining the live classes. Some of them might would have watched the recorded lectures basically. So that is their issue. That's not our issue. Correct? So please do not believe in all these false rumors. Okay, the most unlikely representation of resonating structure of para nitrophenoxide ion is? What do you think? And by the way, there is one more crash course which is going to come, right? That is going to be a 45 days live crash course. Perfect. That will be launched soon. 45 days crash course, and that will be at very minimal cost. That will be particularly for NEET 2024. Okay. So what do you think is the answer of this particular question? I can see majority of the students are coming up with option C. If you look at option C, over here nitrogen is forming 1, 2, 3, 4, 5. 5 bonds. Have you ever seen nitrogen forming 5 bonds? Have you ever seen nitrogen forming 5 bonds? Don't say yes. Okay, compare the bond lengths. 1, 2, 3, 4. You have to compare these bond lengths, guys. Compare these bond lengths. Compare these bond lengths. Yes, Medico, there'll be tests also in the crash course batch. Okay. On 20th, I'll be launching that. The 45 days crash course for NEET 2024 at the rate of very minimal cost so that everybody can afford it. But dear students, if you look at this particular bond between nitrogen and carbon, it's a pure single bond, and this one is a pure double bond, right? This is pure double bond, pure single bond, right? Over here, nitrogen has got the lone pair. Over here, nitrogen has got the lone pair as well. So what will happen here? Resonance will happen, correct? Resonance will happen. Due to resonance, 3 and 4, they will get partial double bond character. They'll get partial double bond character. Perfect. Pure single, pure double, right? Perfect. So pure double bond, its bond length will be least, right? And one will have maximum bond length. One will have maximum bond length because it's pure single bond. It's pure double bond. Maximum bond length, minimum bond length, right? Now, maximum bond length, minimum bond length. Among 3 and 4, due to resonance, they are getting what? Partial double bond character. Now, where is the resonance more? Resonance is more in this particular case, pi, sigma, lone pair. Resonance is more here. More the resonance, more the double bond character here. More the double bond character, lesser the bond length. So 4 will have lesser bond length than that of 3, right? 1, 3, 4, 2 has to be the order. Everyone aligned? And a lot of students were asking, sir, can you ever teach organic? In that particular batch, I'll be teaching organic. Okay, the crash course batch is going to come. In that particular batch, I'll be teaching you organic as well. Achha, chalo. Look at this one. Atomic structure one shot will be posted after 3 to 4 days on this channel. Quickly, arrange the following according to their stability order. Quickly, guys, quickly. Stability order. See, one thing I believe you would be remembering by now. Negative charge holding capacity of oxygen. Negative charge holding capacity of oxygen is greater than the negative charge holding capacity of almost 10 carbon atoms. Do you know that? Negative charge holding capacity of oxygen is greater than the negative charge holding capacity of almost 10 carbon atoms. From here, you can understand how stable negative charge on oxygen is, right? See, over here, due to resonance, the negative charge can come on 2 oxygen atoms, right? Perfect. The negative charge is shared between 2 oxygen atoms. So I would say in the first case, maximum stable, right? Now here and here, there is no oxygen here, there is oxygen here. So C will be definitely more stable than that of B. There is no need to think a lot. Only remember one thing. Negative charge carrying capacity of 1 oxygen atom is more than that of negative charge carrying capacity of almost 10 carbon atoms, right? Perfect. Perfect, guys. Perfect. Okay, one more question based on stability of carbocations. One more question based on the stability of carbocations. What do you think about this one? One more question based on the stability of carbocations. What do you think about this one? See guys, look at the groups. OH present at the para position. Which effect it's going to show? Which effect it's going to show? OH at the para position. Quickly. Which effect? Plus N, right? OH at meta. Which effect? Minus I. Nitro at para. Minus M. Nitro at meta. Minus I. SH at para. Plus N. Right? Now you have to arrange these carbocations on the basis of stability order, right? I believe you know stability of carbocation. Carbocation is stabilized by electron donating groups. And you know plus M dominates over plus H dominates over plus I, right? Plus I, after that I'll write minus I. I'm writing the order which you are going to remember. After minus I, it's going to be minus H, and then it's going to be minus M. This is going to be the stability order. This is going to be the stability order. This is going to be the stability order, right? This is going to be the stability order. So that carbocation wherein you have plus M showing group, right? That will be more stable, followed by plus H, followed by plus I. Now accordingly you can choose your answer. Accordingly you can choose your answer here. So plus M. This is plus M and this is plus M. Now which one is more plus M showing? Over here, it'll be 2p, 2p overlap. It'll be 2p, 3p overlap here, right? So I would say first one is more stable than that of 5. So first and fifth over. Perfect. Is there anyone showing plus h? No. Anyone showing plus I? No. Anyone showing minus I? Yes. Minus I, right? Okay. Minus I of this, minus I of this. But nitro group shows more minus I. So nitro is more withdrawing than this OH. If this is more withdrawing groups, they decrease the stability, right? So I would say 2 will be more stable than that of 4, and at the end you will give priority to 3. Anyone give this as the answer? Anyone give 1, 5, 4, 2, 3? Someone is saying 1, 5, 4, 2, nahi. 1, 5, 2, 4, 3 will be the answer, right? 1, 5, 2, 4, 3 will be the answer, right? I think you're confused between this 2 and 4. I mean 2 and 4. This is minus I. This is also minus I. Perfect. But nitro is more minus I showing, more withdrawing. More withdrawing means it will destabilize more. It will destabilize the carbocation more, right? So stability of 2 will be more than that of 4. I hope it's clear now. You have to be careful with these things as well. You have to be careful with these things as well. Okay. Questions based on acidic strength. Questions based on acidic strength. What do you think? These sort of questions, I believe we have solved already. Quickly, guys. You know, your acidic strength of the acid is directly proportional to stability of the conjugate base, right? Acidic strength of the acid is directly proportional to stability of conjugate base, and conjugate base is stabilized by electron withdrawing groups. Conjugate base is stabilized by electron withdrawing groups, and in the electron withdrawing groups, we give priority to minus M first, then minus H, then minus I, then plus I, then plus H, then plus M. This is the rule which you have to remember. That's all. Nothing else. Done and dusted, right? Done and dusted. Okay, ROH, RSH. If you take H positive out, it becomes RO negative. If you take H positive out, it becomes RS negative. These are the conjugate bases. These are the conjugate bases, right? Oxygen carrying negative, sulfur carrying negative. Oxygen, sulfur, they belong to same group, volume charge density. More size, less VCD, more stability. So this is the stability order of conjugate bases, and whatever is the stability order of conjugate bases, same is going to be the acidic strength order. Same is going to be the acidic strength order. Simple. Take H positive out everywhere. This becomes CH3 positive. Sorry, CH3 negative. This becomes NH2 negative. This becomes OH negative. This becomes F negative. These are their conjugate bases. Negative on carbon, negative on nitrogen, negative on oxygen, negative on fluorine, right? Fluorine, oxygen, nitrogen, carbon, they belong to same period. So electronegativity. Negative charge is more stable on more electronegative element, right? So this is the stability order of their conjugate bases, and whatever is the stability order of their conjugate bases, same is going to be the acidic strength order. We have discussed this in detail, if you remember. H2O, H2S, take H positive out, it becomes OH negative. Take H positive out, it becomes SH negative, right? These are the conjugate bases. Oxygen carrying negative, sulfur carrying negative. Oxygen, sulfur, same group, VCD, right? More size, less VCD, more stability. So this is the stability order of the conjugate bases. So this has to be the acidic strength order. Simple, correct? Take H positive out, negative on carbon, negative on carbon, negative on this carbon, correct? This is a triple bonded carbon. More electronegativity, more S character. Negative charge is more stable here, right? So this conjugate base over here will be more stable. So what will be the acidic strength order? Same. Correct? Okay, what do you think about this one? What do you think about this one? Among these two, which one is more acidic? Which one is more acidic? I'm asking you. Which one is more acidic? Quickly. Quickly. You should be answering this question, by the way. You should be in a position to answer this question. You should be in a position to answer this question. You take H positive out from here. This is carbon carrying negative, conjugate base. Take H positive out from here, conjugate base. This is sp hybridized carbon. This is sp3 hybridized nitrogen. electronegativity of hybridized carbon is more. So negative charge is more stable on this carbon. So conjugate base is stable in the first case, right? More stable the conjugate base, more is acidic strength, right? I hope you are remembering all these small things, small facts. Okay, here you might do a mistake, maybe, but no. Okay, A, B, C. Which one is more acidic? Which one is more acidic? First of all, look at the reference from where hydrogen is going to leave as H positive. This is the reference from where hydrogen is going to leave as H positive. Now, Cn, present at meta position. It will show minus inductive. CH3, it will show plus inductive, right? F, it will show minus inductive, right? Acidic strength, in short, is directly proportional to what? Electron withdrawing groups. This is withdrawing, this is withdrawing. Now, which one is more withdrawing? Can you solve it easily? Just on the base of inductive effect, because all these groups are present in the meta positions, right? At meta positions, there will be no mesomeric, no hyperconjugation, nothing. Right? Okay, can you tell me the answer of this particular question? Which one will be more acidic, A, B, or C? I just want to know. A, B, or C. What do you think? A, B, or C. Which one is more acidic? What do you think? A, B, or C? Quick. Which one is more acidic, A, B, or C? I just want to know what you think about this. See, guys, first of all, you should be knowing, I have discussed with you in detail in the marathon as well. I have told you that carboxylic acids are better acids than your phenols. Carboxylic acids are better acids than your phenols. This is carboxylic acid, this is carboxylic acid, and this is phenol group, right? So, I would say B will be least acidic, then A and C, then A and C, then A and C. Now, among A and C, which one is more acidic? Here you have got withdrawing. Withdrawing groups, they increase the acidic strength, right? So, C will be maximum, followed by A, followed by B. Is it clear? Is it clear, guys? Is it clear? Madan, isomerism HSP sir already has taken. Okay? Isomerism HSP sir already has taught. You can consult those lectures as well. Okay, 1, 2, 3. A very basic question. Very basic question. Acidic strength directly proportional to electron withdrawing. This is withdrawing, withdrawing, withdrawing. 3 withdrawing, 2 withdrawing, 1 withdrawing. So, C will be maximum acidic, followed by B, followed by A. Correct? This is here carboxylic acid. This is your phenol. This is your phenol. Carboxylic acid will be maximum acidic, right? Now, among B and A, here NF3 positive, more withdrawing, right? So, A, then I'll give priority to B. Are you following all this? Are you following all this properly? Yeah? Okay, among first and second, which one is more acidic? I want to see how much you remember. Among first and second, which one is more acidic? You have got CHF3 and CHCl3. Which one is more acidic? What do you think? Which one is more acidic? What do you think? I want to see how much you remember. Are you sure? Amazing, guys. Great. Amazing. So make their conjugate base, take hydrogen out as H positive. This will be CF3 negative. Right? Take hydrogen out as H positive. This will be CCl3 negative. Perfect. These are the conjugate bases. Now, where do you see the conjugate base more stable? See, over here carbon is attached with fluorine. In fluorine, there are no vacant orbitals. But here carbon is attached with chlorine. In chlorine, there are d orbitals, vacant d orbitals. Right? Vacant d orbitals in chlorine. So there can be back bonding. Due to back bonding, I'll say this conjugate base will be more stable. And if this conjugate base is more stable, its corresponding acid will be stronger acid. Right? Amazing. Among first and second, which one is more stable? Quickly. Among first and second, which one is more stable? First or second, which one is more stable? What do you think? First or second, quick. First or second, quick. Again, you can follow the same rule. Take hydrogen out as H positive negative charge here. Take hydrogen out as H positive negative charges here. Now, sulfur has got vacant d orbital. There can be back bonding. There can be no back bonding. There is no back bonding. There is back bonding. Back bonding stabilizes the conjugate base. So acidic strength order will be this. Right? Amazing. Good. All right. Let me see if you can solve this question or not. Arrange the following as per their acidic strength. See, this is the reference from where hydrogen is going to leave as H positive. This reference is common to everybody, right? Now, you have to arrange on the base of the groups. See guys, can you let me know which effect this is going to operate? Just let me know in the chats. Which effect CH3 is going to operate? It is at para, so plus H, right? CH3 at meta, so plus I. CCl3 minus H from para, right? CBr3 minus H from para. CCl3 minus I from meta. You know, from meta in mesomeric and hyperconjugation does not operate. Now, acidic strength. As I told you already, acidic strength is directly proportional to stability of conjugate base. Stability of conjugate base. And conjugate base is stabilized by electron withdrawing. And in electron withdrawing, you give priority maximum to minus M, followed by minus H, minus I. This is plus I, and this is plus H, and this is plus M. This is the order which you will be following. Right? This is the order which you'll be following. So is there anyone showing minus M? There is nobody showing minus M. Is there anyone showing minus H? Yes, this and this. They are showing minus H. They are showing minus H. Correct? Now, which is showing more minus H? CCl3 or CBr3? I just want to see whether you remember or not. Among these two, which one is showing more minus H? CBr3 or CCl3? If you remember in the series I have mentioned, CBr3 is showing more. CBr3 shows more minus H. You have to remember all those things. So 4 followed by 3. So H is over. H is over. Is there anyone showing minus I? Yes, there is one showing minus I. That is the fifth one. After minus I, is there anyone showing plus I? Yes, there is one showing plus I. That is the second one. Is there anyone showing plus H? Yes, there is one showing plus H. That's one. First case. After plus H. Is there anyone showing plus M? There is no plus M. This is the order. 4, 3, 5, 2, 1. Did you write the same? 4, 3, 5, 2, 1? 4, 3, 5, 2, 1. Yes. Amazing. Good job. Good job, guys. Good job. Okay. This was asked in the NEET examination as well. This question. Quick. Quickly. In the last question, I had mentioned in the marathon itself, CBr3 shows more minus hyperconjugation than that of CCl3. Yeah? Quickly, people. Give it a try. Give this question a try. Quickly. First of all, we have to check this acidic strength only. I mean, the reference everywhere is same. The reference again everywhere is same. I mean, this is the place from where hydrogen is going to leave as H positive. You know it. You should know it by now. Now, this Cl, which effect? Which effect? For halogens, inductive effect is more dominating than mesomeric. For halogens particularly. It can show minus I, it can show plus M. But for halogens, inductive effect is more dominating than mesomeric. You know it. Okay. Now CH3. CH3 is present at para. So plus hyperconjugation. NO2 at para minus M. OCH3 plus M. Right? And order you already know. Acidic strength order. Acidic strength of the acid is directly proportional to stability of conjugate base. And this conjugate base is stabilized by electron withdrawing groups. And in the electron withdrawing groups, we give priority to minus M first, then minus H, then minus I, then plus H, then plus M. This has to be the order, right? This has to be the order. So what do you think is the answer now? What do you think is the answer now? So minus M is given priority first. So third will be maximum acidic. Third will be maximum acidic. And there is only one option which is showing third is maximum acidic. So C. C is the answer. Directly, right? Rest you can check on your own. I believe you can do that. I believe you can do that. Okay. I believe you can do that. All right. What do you think about this one? Quick. Which of the following has lowest pKa? Lowest pKa. In equilibrium, I would have told you some time before. More the Ka, more the Ka, more is going to be the acidic strength, and lesser is going to be the pKa. That's it, right? Which of the following has the lowest? Lowest pKa means maximum acidic strength. Now, among all these, where do you see is the acidic strength maximum? Where do you see is the acidic strength maximum? Where do you see is the acidic strength maximum? First of all, check the reference. This is the reference from where hydrogen is going to leave as H positive, right? Okay. Over here, there is one withdrawing group. There is one withdrawing group. This is CCl3. 3 chlorines are attached, only 2 chlorine attached, right? More chlorines attached means more acidic strength. More acidic strength means lesser pK. Lesser pK means more Ka. So C has to be the answer. C has to be the answer. What do you think about this one? This question was asked in 2010. Which of the following compounds has the most acidic nature? Most acidic nature. What do you think? Most acidic nature. Which of the following? Most acidic. That one is going to be more acidic whose conjugate base will be more stable. That one is going to be more acidic whose conjugate base will be more stable. If you take hydrogen out as H positive, there will be negative charge on this oxygen, right? This negative charge is not resonance stabilized. But if you take H positive out from here, there will be negative charge on this oxygen. But this negative charge is resonance stabilized, phenoxide ion, right? Here it is not resonance stabilized. Here the negative charge is not resonance stabilized. So where is the negative charge more stabilized? In case of B, because of resonance, right? So wherever conjugate base is more stabilized, right? The acid is going to be stronger. Done, right? As well as dusted. Arrange the following on the base of their basic strength. I hope you remember the basic strength rule. Wait. Basic strength rule, I hope you remember. Basic strength is increased by electron donating groups. Basic strength is increased by electron donating groups. And in the donating groups, plus M is given maximum priority, followed by plus H, followed by plus I, then comes your minus I, then comes your minus H, then comes your minus M. This is the order which you have to follow when it comes to the basic strength. I believe you remember it. I've discussed this in detail in the marathon. I've discussed this in detail in the marathon. First of all, you have to check the reference. This is the reference. This is the reference, which is same everywhere, right? This is the reference, which is same everywhere. Now people check. This is OH. OH is at the para position, so plus M. This will also show plus M. O negative. This will also show plus M. CH3 at meta, plus I. Plus I. Okay. Now, first of all, if you remember one statement which I told you, which I have told you already. Plus M power, plus M. Since this showing plus M, plus M, plus M, plus M power of anionic groups. Plus M power of anionic groups. Right? Plus M power of anionic groups is more than that of plus M power of neutral groups. Do you remember? Plus M power of anionic groups is more than that of plus M power of neutral groups. Right? So plus M, maximum plus M is shown by third, maximum basic. Now among these two, OH or SH, here it will be 2p, 2p overlap. Here will be 2p, 3p overlap. So this overlap is more prominent. So 1, then comes 2, and at the end it will be 4. 3, 1, 2, 4. Anyone give the same answer? 3, 1, 2, 4. 3, 1, 2, 4. Agreed? Perfect. Moving ahead. Moving ahead. Moving ahead. Quick. What about this one? What about this one? Arrange the following according to their basic strength. First of all, check your reference. Check your reference. This is the reference which is common everywhere. This is the reference which is common everywhere. CH3 at para plus hyperconjugation. CCl3 at para minus hyperconjugation. CH3 at meta plus inductive minus inductive. These are the effects which they are going to operate. Right? Now, is there anyone showing plus M? No. Is there anyone showing plus H? Yes. So A will be maximum basic. After plus H, we give priority to plus I. Is there anyone showing plus I? Yes. Plus I. After plus I, it is minus I. Minus I. Right? After minus I, it is minus H. So this is the order. Is it? Done? ACDB is the order. Now, can you arrange them like which one is aromatic, which one is anti-aromatic, and which one is non-aromatic? I believe all the aromatic, anti-aromatic, non-aromatic will be clear from here only. See guys, 2, 4, 6. 6 pi electrons are involved in the cyclic conjugation. The molecule overall is planar, right? It is cyclic. It is cyclic, there is complete cyclic conjugation, and 6 pi electrons are involved. That means it's following the Huckel's rule. If it is following Huckel's rule, it has to be aromatic. Perfect? Perfect, guys? Okay, can you tell me what is the hybridization of this sulfur? What is its steric number? Its steric number should be 1 sigma, 2 sigma, 1 lone pair, 2 lone pair. Its steric number has to be, since it's forming 2 sigma bonds and 2 lone pairs, its steric number should be 4. Its hybridization should be sp3. But we know that lone pair which is conjugated, that lone pair which participates in resonance, that is not counted for hybridization. I hope you remember. That lone pair which is there participating in resonance, which is conjugated, right? We do not count that for hybridization. So we'll be only counting 1 sigma, 2 sigma, and only 1 lone pair. So 2 plus 1, 3. Steric number here is 3, so it's sp2. That is the reason why it's planar, right? We have discussed all this. Okay, this is aromatic. What about the next one? What about the next one? 2, 4, 6, 8, 10. So 10 pi electrons, aromatic, right? Huckel's rule 4n plus 2 pi. This is sp3 hybridized, so non-planar, non-aromatic. sp3 hybridized, non-planar, non-aromatic, right? Only 2 pi electrons involved in the cyclic conjugation, so it is going to be aromatic following Huckel's rule. 2 and 4 pi electrons, so it is anti-aromatic, right? Perfect. 2 plus 1, 3 pi electrons. 3 pi electrons, neither aromatic nor anti-aromatic, so it's non-aromatic, right? Only 2 pi electrons, aromatic. sp3, non-planar, non-aromatic, right? That's how you do it. I hope you know. I hope you remember. We have discussed this a lot in detail. There was a question asked in NEET 2023. I mean, last year a question was asked from this. Consider the following compounds, the number of compounds or species which obey Huckel's rule. Huckel's rule is 4n plus 2 pi electrons should be involved in the complete cyclic conjugation. They should be involved in the complete cyclic conjugation. That means if n is 0, either 2 pi electrons. If n is 1, 6 pi electrons. If n is 2, 4 to 8 to 10, 10 pi electrons. If n is 3, 4, 3, 12 to 14, 14 pi electrons, right? Right, people? If these many electrons are involved in the complete cyclic conjugation, we say the molecule follows the Huckel's rule, right? Over here, if you look at the first scenario, 2, 4, 6, 8, 10. 10 pi electrons are involved. 10 pi electron means Huckel's rule. Yes, right? 2, 4, 6. 6 pi electrons involved, right? 6 pi electrons, it's following Huckel's rule. 2 to 4. 4 pi electrons, it is not following the Huckel's rule, right? 2 to 4, not following Huckel's rule. 2. Yes, 2 following the Huckel's rule, right? 2, 4, 6, 8. 8 pi electrons. 8 is not here, so it's not following. 2, 4, 6, 8, 10, 12, 14. 14 pi electrons, yes. How many species are there? There are 4 species basically which are following the Huckel's rule. Perfect, people? Perfecto. All clear? And let me tell you, we have discussed all this in detail. I hope you guys remember, by the way. I hope you guys remember. NEET 2022, one more question was asked. NEET 2022, one more question was asked. By the way, all these questions, whatever I have come up with, this is the combination of your PYQs, NCRT exercise, and NCRT in-text question. This is the combination of everything. Which compound is not an aromatic compound? Not an aromatic. That means neither aromatic nor anti-aromatic. Neither aromatic nor anti-aromatic. What do you think? See, 2, 4, 6. 6 pi electrons, aromatic. Right? 2, 4, 6. 6 pi electrons, aromatic. Right? 2 pi electrons, aromatic. 2, 4, 6. 6 pi electrons. And here, it's attached with 2 hydrogen atoms as well. So it is sp3 hybridized, non-planar. Non-planar means non-aromatic. So what is my answer? It has to be option 4. Option 4 is neither aromatic nor anti-aromatic. It is non-aromatic, right? I believe it's clear. One more question. Even this again one asked question. Tell me the answer quickly. Among the following, the aromatic compounds are. Among the following, the aromatic compounds are. Among the following, the aromatic compounds are. Quick. See, 2 to 4, 4 pi electrons means anti-aromatic. It's not an aromatic. 2, 4, 6, 6 pi electrons, aromatic. 2, 4, 6, 6 pi electrons, aromatic. 2, 4, 4 pi electrons, anti-aromatic. So B and C basically, right? B and C. Yeah? Done? B and C. And guys, these are what you call as easy questions, and you should be able to solve them within 20 seconds, right? They are going to say, these questions are going to save your time in your actual examination center. Compare the stability. Again, you are going to compare the stability on the basis of same. See, this sp3, non-aromatic, 2 to 4 pi. Anti-aromatic, 2, 4, and 6. 6 pi. Aromatic, right? Aromatic compounds are maximum stable, followed by non-aromatic, followed by anti-aromatic. Followed by anti-aromatic, right? So, it is 3, followed by 1, followed by 2. 3, 1, 2. Right? So this is the option. Correct? See what kind of question was asked in NEET 2020. A tertiary butyl carbocation is more stable than secondary butyl carbocation because of which of the following? A tertiary butyl carbocation is more stable. A tertiary butyl carbocation is more stable, right, than that of secondary butyl carbocation. Because of what? Carbocations are stabilized by hyperconjugation, right? Perfect. So it's hyperconjugation basically. This one question I'm giving you as the homework, and this is the last question of the session, and I would want its answers in the comment section. First of all, in the comment section, I would want its answer, and at the same time, do let me know which chapter you want the next for the question practice. Okay? I would want every one of you to let me know in the comments which chapter do you want the next for the question practice. Okay? Right? And at the same time, not in the chats, in the comments afterwards. In the comments, I'm saying. Number 1. Number 2, in the upcoming days, on 15th, we are having a live session in the evening, Game of NEET, wherein we are going to complete the thermochemistry part, right? Thermochemistry part. And after that, after 3 days after that, you will get a one shot, but that will be a recorded lecture of 9 hours almost, in which complete atomic structure I'm doing, right? I've started doing the recording for it. atomic structure, which will be posted soon. Do let me know in the comment section of the video, like which chapter do you want the next. I believe this session was perfectly clear to everyone, and I believe your GOC got completely revised, right? And you got to know exactly what kind of questions can be asked. Okay, hope this particular session was beneficial for all of you, and hope this particular series will be beneficial for all of you as well if you follow it with 100% honesty, my dear students, right? Okay, surely from the next question practice session, there'll be assertion reasoning questions also involved. Okay guys, chalo, I'll be taking a leave with this. Thank you, God bless you all. See you in the next live session. Till then, you guys take care. Bye-bye.